Happy Wednesday, you guys. It was great to hear from y'all yesterday. Today we are going to talk about Lewis dot structures. And so we have a POGL and a pretty short set of notes with a response sheet. This assignment will be due on Friday, and so I'll make sure that I include that in the assignment description. And let's go ahead and jump in. So we've pretty much, to this point, spent a lot of time using Bohr models to look at atoms and how they are shaped and how they're behaving, but Bohr models are cumbersome to draw and they take a while, and so we want to do it in a more simple way. So a Lewis dot structure allows us to do that because it's a diagram that represents only the valence electrons, and it's super simple. Most commonly used to depict covalent and covalent bonds in molecules because if we have an ionic bond, they're just acting like little magnets, so they're trading electrons, and so that is depicted really differently than how we depict covalently bonded substances. And all it consists of is the atomic symbol with its valence electrons. So in the example to the right, we have the Bohr-Rutherford model that we've talked about many times for potassium. And then to the right of that, we have the Lewis diagram, which only has the potassium K, the symbol K, and the valence electron, because potassium only has one valence electron. So the steps to drawing a Lewis structure for a single atom are pretty simple. So you determine the number of valence electrons, and you can either draw a Bohr model or you can use the rule from the periodic table. Whichever one seems easier to you is fine. Then you write the chemical symbol of the atom to represent the nucleus. So that chemical symbol is telling us which element the atom is and how many protons it has. Last thing is to draw the valence electrons, and you cannot have more than 8 dots on a Lewis dot diagram because you shouldn't have more than 8 electrons in your highest energy level. Sometimes there's dots by themselves, and we call those unpaired electrons. So here's a couple of examples. We have nitrogen, phosphorus, magnesium, and calcium. And I've put in their Bohr models. And so we want to just be looking at the outermost gray stripe for each of these circles to find out how many valence electrons each has. And the little dots are, of course, the electrons. So for nitrogen, there's 5 little dots in the furthest gray ring. So it has 5 valence electrons. So it needs to have 5 valence electrons on its Lewis dot structure as well. So I put the atomic symbol in for nitrogen in the middle, and then I just draw 5 dots around it. If you wanted to, you could draw like 2 paired together and 1 by itself. You can draw 1 pair together and 3 by themselves. It doesn't really matter. Ultimately, if we had 8 valence electrons, we would put 2 on each side, and then one pair on the top and 1 pair on the bottom. Phosphorus also has 5 valence electrons, even though it's much bigger than nitrogen. And so you draw its Lewis dot structure almost exactly like nitrogen's, except you sub out the atomic symbol for nitrogen and replace it with phosphorus. Magnesium only has 2 valence electrons, and so we would just draw those 2 dots next to the magnesium. Again, some people really like to have them spaced out the way they're drawn here. I don't care too much if you had drawn both of the dots on top of the M or both of the little dots next to the G. That's totally fine. We also have calcium, which has 2 valence electrons, and its Lewis structure is exactly the same as magnesium's because of that. So there's some patterns within the periodic table in terms of those valence electrons. And because of that, anything that's in the same family, so the same column, those guys are going to all have the same Lewis dot structure, which is kind of nice to know. All right, I would like you guys to take a minute to try to create a table like what I did. You do not need to include the Bohr model, but it might be useful and helpful. And so I made this table in your student response sheet. So you should fill it in by just clicking in the box for valence, telling me how many valence electrons each one has. And then to make the Lewis dot structure, if you double click on the question mark, it'll open a drawing. You can delete the question mark and replace it with the chemical symbol. And then you can move the little red dots around the symbol until you have all of the little dots that you need. Okay, so here is the key. You should have found 3 valence on aluminum, 7 on fluorine, 6 on sulfur, and 1 on sodium. Because of this, each of these Lewis dot structures looks very different because all of these elements have a different number of valence electrons. Aluminum has 3 dots, fluorine has 7, sulfur has 6, and sodium has 1. And so this can make it pretty easy to see that it might be simple to take this electron away from sodium, and indeed it is, but it's probably easier for fluorine to just take an electron instead of trying to give all 7 of these away. So this starts to allow us to predict what kind of chemistry the atoms are going to do. Lewis dot structures are particularly powerful because they give us a really concrete way to depict molecules and their structures in 2 dimensions. You guys don't need to know how to draw molecular Lewis structures. I only need you to be able to draw the atomic ones, but we have to understand what the molecular Lewis structures mean so that we can use them and talk about them. So we're just going to look at a couple examples. First example is water. Its molecular formula is H2O. These questions are also in your student response sheet, so you should pause the video and try to answer them. They say, how many different elements are present in this molecule and what are they? How many total atoms of each element are present? What kind of bond do these elements form? And what happens to electrons in this kind of bond? Are they shared or transferred? Okay, so I want you guys to take a little time to think about that. And we're back. So how many different elements? So there's 2 types of elements. There's hydrogens and there's oxygen. How many total atoms are there of each element? You have 2 hydrogens, 1 oxygen, so 3 atoms total, but only 2 types of elements. What kind of bond will hydrogen and oxygen form? Well, they are both nonmetals, and so they will make a covalent compound. So they'll make a covalent bond. When electrons are in a covalent bond, they are shared and not transferred. So somehow we want to depict the hydrogen having access to the electrons and oxygen having access to the electrons as well. And that looks like this, right? So what do you think the line between the atomic symbols represents? And what kind of bond holds the hydrogens and the oxygens together? So our bond is represented by the line. So the line represents 2 electrons, and we just draw them as lines because otherwise we'd be drawing a lot of dots and that would be annoying. Okay, and that covalent bond is what's holding the oxygen and the hydrogen together. All right, this one's a lot more complicated, but it's actually not too hard to understand, even though it looks impressive. So please pause this and try to answer the questions. How many different elements are present in this molecule? What are they? How many total atoms of each element are present? And what do the lines between the atomic symbols represent? So we have three different elements: hydrogen, oxygen, and carbon. And the totals of each, there are 6 carbons, 6 oxygens, and 12 nitrogens. Not nitrogens, oxygens. Sorry. What do the lines represent? Well, the lines represent the same thing they did in the water. They represent shared electrons. So each line stands for 2 electrons that are being shared between the 2 atoms that the line touches. Some more questions to analyze this guy. What does the line connecting carbon to oxygen on the right side, why does it have 2 bonds or 2 lines? And so it has 2 bonds because that way the carbon and the oxygen are stable, and that's a really strong bond. These guys are forming covalent bonds, and so they're sharing their electrons. So carbon and oxygen with that double bond, those 2 lines, it's like double sharing electrons, which is, a really nice thing to do. Hopefully this helps you dive into your POGL, and like I said, this will all be due on Friday. I love you guys very much. I will talk to you soon.